Grazie. Buongiorno. Now we have to switch to English because I cannot talk. Sorry for that. I have to excuse because I have to leave very early. My flight is at 1 o'clock, and so I have to make a very quick presentation. I want to present some results of our research project we have finished last year, and the things which I will present is a collaborative work from Philipp Mayr, my colleague, and by myself. First, I can say some things about our research institute in Bonn. We are building digital libraries and hosting data archives. We are doing consulting for social science questions. We are performing surveys and studies and things like that. And it's a quite huge institute with around 200 persons. Half of them are researchers and half of them are staff. We have to deal with different types of documents. We have a lot of bibliographic databases. We have lots of full texts to manage. We have project data. We have data about institutions. We have web pages to manage. We have statistical data, and we are dealing with different disciplines with our services. First of all, social science and the social sciences as discipline, but also political science and education, psychology, and things like that. And the things I will present have to do mainly with these disciplines. The main problem we have if we are building large digital libraries is that we have heterogeneous collections. We have a lot of databases to include in our systems, and most of the databases have different document types, different formats, and different vocabularies. And the focus of our project is to bring together the controlled vocabularies, the thesauri, classifications, and descriptor lists. And this is our main field of work. And what we can see is that on the database level, the internal consistency concerning the controlled vocabulary for one database is very high, and if you go into a multidisciplinary or a multi-database scenario, you have a very weak inter-system compatibility. And what we are doing is this is what we call semantic heterogeneity. And the solution I will present is where you translate between these controlled vocabularies. And the product we have is what we are producing crosswalks. We call them cross-concordances, and this is what we call terminology mapping. You have to map between different controlled vocabularies to search seamless in a multi-database scenario. And that's exactly what we have done and what we have measured in our experiments. I'm reporting about the COMOHE project. It was a project running about 3 years, and the main goal was to build up these crosswalks between controlled vocabularies and to evaluate the effectiveness of these crosswalks. This is an overview for some terminology mappings out of the German environment. We have huge terminology services in the US, mainly performed by OCLC. Perhaps some people know this organization. We have the MAX project between three main very huge vocabularies conducted by national libraries. We have the Carmen project conducted in Germany, and the Crisscross project also in Germany. What are crosswalk lenses? What are these crosswalks between controlled vocabularies? You can call these vocabularies as knowledge organization systems. I think you know this. And what we have done is we have manually created directed relations between single terms. That's the main focus. And what you can see here is we took always, not always, but most of the time, we took whole systems, terminology systems. This is an example. Do you have a pointer or something like that? No. No pointer? Okay. This is an example that we have reconciled every term 100% of the cost number one. And we have translated these 100% of the terms into 50% of the other cost, because the cost 2 is more general than cost 1, and we cannot map 100% to 100%. Okay, the rest is that's very good to see. So I come back to one example. Here you can see the bilaterally construction of such a mapping. We have the term computer, the control term computer in system 1, and this term is transformed or translated into information system in cost number 2. But if we are going back, the back direction, the bilateral way, going from information system back to, not back to computer, but to database. So we have not a completely symmetrical mapping, but a mapping between 3 terms altogether. Okay, here are some examples for relation types. We have the most important relation type is equivalence. To map one term to the semantic equivalent in the second system. You can see here library. Library is translated into bibliothèque in a French system, perhaps. But we have also other relation types because you're not always in the situation that you can transform equivalent. We have narrow term, typical thesaurus relations. One specialty is here the null or the no mapping relation. It just means that you cannot translate one term. Here, virus in one system cannot be translated into the system 2 because it's about social science, and because virus has no meaning there, no impact there. Okay, this is the result of the project. We have translated or combined or connected is better, connected 25 different vocabularies. That's quite a lot. And the net here, it's not very clear to see, but in our paper I have referenced at the end of the presentation, you can have this clearer. This is the net of mappings between different knowledge organization systems. And you see here one thesaurus which is very central in our field. It's just for an overview, and altogether we have more than 500,000 of relations, all conducted intellectually. That's quite a lot. Okay, that's an overview of the net. Concerning the disciplines, where the different control vocabularies are from. You see here in the middle, we have 10 social science vocabularies connected to political science. The numbers in the brackets are the number of control vocabularies. And you have here three political science vocabularies, 2 from economics, and so on. And not every not every control vocabulary is connected to every other vocabulary in the net, but interesting combinations between social science and political science, or political science and economics, and these are mapped directly. Okay, we have a lot of problems if you're conducting or managing such a lot of relations. First of all, you have to look at the different vocabulary types. We have thesauri, we have classifications, we have descriptor lists, and if you're combining or translating a classification to a thesaurus or a thesaurus to a classification, it's completely different work. And our main mappings are in the field of thesaurus-thesaurus mappings. That's the most simple combinations, I think, and that's our main focus here. But the possibility to map classification to a thesaurus is here, and we have some experimental data where we have conducted these connections. I can show some pictures later. You have additionally, you have problems between disciplines. It doesn't make sense to connect the math discipline to social science. It's not very similar, and you should skip such a project, I think. We have problems between languages, German-English. German-German is more simple. We have problems with the sizes of the different vocabularies. We have very huge ones, like the mesh. The mesh system is about 22,000 terms, and we have larger vocabularies like the DDC with 200,000 connections. But if you have vocabularies in this size, you have to take parts out of it. That's what we're doing. That's an overview about the distribution of relations. We have a lot of equivalence relations. These two parts of the graphic, altogether more than 40% equivalence relations. We have quite some known mappings, but no mapping possible. We have broad terms, we have narrow terms, and related terms. Just a picture, or just to give you an overview how the relations are scaled. This is and this was for thesaurus mappings, our main field. We have one experiment where we have mapped classifications to thesaurus, or one classification, the jail system, to a German economics thesaurus, and there you have a completely different picture. But it's not the main focus of my presentation to discuss these graphics, so I skip this. The main thing I want to present is the retrieval test we have done. Because if you are producing such a lot of relations, you have to measure how effective are these mappings, and that's what we have done. We have done huge retrieval tests with more than 80 topics. We have searched in different database settings, and we have done it in a very traditional way, where we measured precision and recall. I think most of the people here are familiar with these two measures, information retrieval. The main goal is, if you do such a mapping, you want to navigate in more than one database without the semantic borders. We call it semantic borders. If you have your query in one controlled system, then you don't want to think about the terms in the connected database. So normally you only want to have one query, and you translate or transform the query into different databases automatically. And that's exactly the application we focus on with these methods. And what we have done is you can put a term or more terms, more control terms in an interface, and you send the terms to a web service, and the web service is producing automatically the fitting terms in the different databases. And that's exactly what we have met in the experiment. These are some additional goals. You want to improve the search experience. You want to increase the diversity of documents if you're going to more than one database. Yeah, that's the goal. Now I want to introduce to explain the treatment test we have done. The first thing was, how good are our mappings, and do these mappings improve subject-specific search control terms? That's the first question. And what we have done is that we have queries, concrete user needs from our colleagues, and these needs or topics were transformed into controlled term queries, and in one start vocabulary, or in one start vocabulary. And these first query is sent to different databases or to one connected database without transformation, and the second run was we translated automatically the query and putting the right terms for the destination database in the database interface and get the result. And this is an example. We have the control term family relations. I don't know the Italian equivalent. But you can translate family relations, what this means.
Relazioni familiari.
Okay, thank you. And in the second database, in the destination database, you have to use the terms family, one term, and social relations, the second term. It's a combined term. And if you are searching family relations, the first one was to search family relations in the destination database. But family relations is not a guilty term in the destination database. That was the first one, and then in the second run, the transformated run, family and social relations, complete correct terms in the second database. That was the first test. The second test, I want to skip this because it's too special and at the time is not enough to explain. Okay, so what we have done, we used just equivalence relations. So the exact semantic, the semantic was equivalent in the connected database. And we have done mostly around six topics for cross-competence, for two database scenario. And we have different database sizes, 80,000 documents to Medline with 16 million documents, a huge amount. And I only want to present the test one here. We have done these experiments with 13 different cross-competences. So what is the result? The result is very positive, as you can see. What you can see is we have split the cross-competences into interdisciplinary databases. Interdisciplinary means that we have two databases in the field of social science, for example, or in the field of economics. And the interdisciplinary cross-competences are psychology to social science, or social science to psychology, or social science to economics, or medicine to psychology. These are typical interdisciplinary mappings. And what you can see is here are the improvements, the recall and precision improvements for a translated search. if you don't translate the topics, no, that's the wrong way to explain it. If you use the transformation, you have nearly 40% more relevant documents in your combined in your destination database than if you don't transform it. So to say, you have an extremely positive effect. You get 40% more relevant documents in the interdisciplinary mappings. So only social science or only economics or only psychology. If you're going into an interdisciplinary scenario, you have 136% more improvement in the result set, and that's immense. If you compare it to traditional ranking algorithm improvements, this is a huge improvement.
5 minutes.
Sorry? 5 minutes. The second experiment was good too, how you can see, but I don't have explained the scenarios, so I don't want to talk too much about this. This is the typical interface we have produced here. You have metadata fields, it's in German, sorry for that, but I think you can, these are fields in our databases, and this is the list of the databases in our portal, so we port. It's 15 different collections. Most of these collections are indexed with different controlled vocabulary. I think we have 13 different vocabularies here. And if you type in this interface controlled terms, you go directly to our web service, and the web service is translating to the right databases, and you are getting combined results from every fitting database. The correct terms are translated or queried in the right database. And you can see that at home if you go to the report. This is an example of our thesaurus. We have an own thesaurus which is connected in this net of cross-references. And what you see here is the English term library. This is a description, typical thesaurus information here used for the combinations and notations. And here you see the cross-competences or the terms in the combined, in the translated databases. You have libraries. It's not completely the same in this database. You have now in this database, you have libraries again, libraries. You have Bibliothekswissenschaft. This is the German term. You have Bibliothek aber German terms mostly. We have most of the mappings are German terms. So, and this result set for the query Bibliothek, library, and global. Both are controlled terms. And what is happening in the background, these both terms are going to the web service. The web service is translating and putting the translated terms into the database and bringing back the results. What is happening in the background? Bibliothek is translated into Bibliotheken, Bibliothekswesen, elektronische Bibliothek, libraries, public libraries, wissenschaftliche Bibliothek. Most German terms, but all different controlled terms in the correct database. And the second term is also translated. Global is translated to Welt. Welt means world. Mondo, I think. Oh, yeah. And these are the correct or the results in the different databases. Here you have social guides, one database, and this is the second database. It's a literature database. So conclusion. Cross-competences improve subject-specific search on a large scale. Also in the controlled term domain as also in the free text search. Free text I didn't present, but the controlled term scenario is the most, is the best scenario in our test. We have only utilized 24% of our relations, just in part of the relations, but the best equivalence relations. We have potential to other experiments or to other applications. We can use our other relations, and we can do the most important thing, that you translate the user terms, the terms that are coming directly out of your interest, into the control term. We have a next project beginning in January where we try to construct or to build search term recommenders where the user terms are translated into control terms, and then the control terms are translated in our scenario. Okay, there are some applications. I want to recommend you this application because the things I presented are very clearly. And next project beginning in January where we try to construct or to build search term recommenders where the user terms are translated into control terms, and then the control terms are translated in our scenario. Okay, there are some applications. I want to recommend you this application because the things I presented are very clearly and clearly explained in this paper. Thank you. Every term we are putting into our system is sent to the transformation services, and if you cannot transform, nothing happens. Just this, no, nothing happens is wrong. This term is going to the databases. But if you can transform, we use the transform terms. No, we have our relation types, and if we have a relation type equivalence, and it's an intellectually constructed relation, we are very sure that that's a good transformation. But you have to test it if it's not a good transformation.
Don't wait for the results.
No, of course. The results are ranked again by different ranking. But that's not the interesting thing. Transformation, more results, you see the recall increase, and then you're ranking again. But you're opening your document space. If you don't transform, you have no documents from this database, nothing, because the term is not guilty.
How do you solve the problem of the linguistic ambiguity?
Linguistic
Ambiguity.
That's solved in our cross-components. The people going to these descriptor lists and understand what the term A in system B means, and then the person is transforming or looking in the connected database or in the connected control vocabulary, and he's reconciling what does this mean in the other system. And so you don't have such a problem like